So finally, we're going to do some solving of equations, exponential equations and logarithmic equations. And you'll see that we need to know both of those types of functions to solve these. Okay, so exponential and logarithmic equations, or logarithm equations if you want. So here's a simple one. Relatively, right? 2e to the x minus 1 equals 5. Now notice the variable is in the exponent. So I'm thinking to myself, I need to get the variable out of the exponent eventually. So eventually I'll have to use a logarithm because that's how you get a variable out of an exponent. And I use a log base e, in other words, ln, natural log, because this is an exponential function base b. But first, this 2 is in the way. So I have to get the 2 out of the way. And so I just cross multiply. In other words, divide both sides by 2. And that goes down. You get 5 halves on the right. Always get that coefficient out of the way before you bring a logarithm into it. Okay? And if I had plus something on the left, I would get rid of that too. You know, like subtract it on both sides. Minus something on the left, I'd add it on both sides. You want to isolate the basic exponential function. Go back to when we first started talking about exponential functions, the very first video or page, if you're looking at the PDF, and you'll see I had the basic one without a coefficient or anything. So, yeah, I'm subtracting 1 from x, but you worry about that later. So now I've got this bare bones kind of exponential function with no coefficient, nothing added on at the end. And now I can take ln of both sides, log base e. Why do I use ln? I could use any base, but ln, first of all, it's something on your calculator, and second of all, and it's commonly used, and second of all, the exponential function was base e, so it's a perfect match. So the ln and the e on the left cancel, and you get x minus 1 on the left, and you get ln of 2.5 on the right. That doesn't bother me because first of all, that could just be part of the answer. It's just a number. But if I want to estimate it, I can just put that in my calculator, no big deal, right? And then I get, add the 1 to both sides or move the minus 1 over and get plus 1. Right? So that's the answer, actually. X equals 1 plus ln 2.5. If it does not tell you to approximate, do not approximate. That's the answer. Get used to it. So a lot of answers look like that. Right? You know it's okay because there's no x on the right-hand side. Okay. So approximate if they tell you to, or if there's some other, really good reason to approximate. Like if you're trying to find the number of seconds and and it's not very accurate, you might just leave it at seconds. I don't know. I can't think of when you would approximate if they don't tell you. Because to approximate, think about it. I mean, if you're putting it on the computer, you have to know what to approximate it to or it's going to mark it wrong, right? Okay, so here, the first one I was solving an exponential equation. 2e to the x minus 1 equals 5. That's called an exponential equation, right? This is another exponential equation. But now I have exponents on both sides. And not only that, the bases are different. Oh my gosh, what am I going to do? So I can't take log base 5 of both sides. I could, but it'll get rid of this 5, but it won't cancel with the 2. Or I could do log base 2 of both sides, and it would cancel here, but it wouldn't cancel here. So I'm just going to do either log base 10 or log base e. Why? Because I like them, A and B. They're on my calculator in case I need to approximate them. Now, how is this going to work? It doesn't cancel. ln is not the inverse function of exponential function base 5. It's just not. And it's not ln is not the inverse function of an exponential function base 2, right? ln is the inverse of an exponential function base e, which is a little more than 2. It's between 2 and 3. And so those don't cancel. But I do have the power rule for exponents. So this power drops down in front, becomes multiplication. Same thing here, but of course that's a binomial, so when you put it in front here, you need parentheses around the binomial because you're multiplying. Okay, so that's what we do. So we can use that fifth property that we had, the exponential rule. It allows us to use any logarithm we want, and we want ln or log, log base 10 or log base e, almost always. If you get into computer science, you'll see sometimes they'll use powers of 2, but special uses, and you'll just learn that in context, so don't worry about it now. So 2x, ln 5 is just a number, right? It's a constant. 2 ln 5 is actually the coefficient of x here. So let's follow these steps here. So what did I do? I took ln of both sides, which you can do. It's ln of the left side, ln of the right side. I'm drawing parentheses here if you can't tell. Okay? And then this drops out in front. This drops out in front, but make sure you put parentheses because you're multiplying this binomial times this number, right? So you get this. ln 2 is just a number. So is this. Now I want to isolate all of the x terms on one side of the equation and the constant terms on the other. So I need to distribute this so I can get to the two terms. So I distributed it. You get ln times x and ln times 1, which is just ln of 2 times 1, sorry. Now, this looks a little odd maybe if you haven't done these before, but ln 2 is the coefficient of x here. But we write it second because if I write ln 2x, it looks like the x is inside the ln. So to make that, so I'd have to put parentheses around the ln 2 if I was going to write the x on the other side. Okay? So to keep it clear, I just write the x on the left. It's kind of like, what is it like? Like square roots. If you have 5 times the square root of 3, you don't usually write square root of 3 times 5. You usually write the 5 in front. If you have x times the square root of 3, you usually write the x first. Right, so it doesn't accidentally end up inside the square root. It's the same thing. If you put the x on the right, it's going to look like it's inside the ln. Okay, so enough of that. So now I want to get the two x terms, these two terms where the variables are x, on the same side of the equation. So I'll just subtract this. Subtract. Right? Don't let the fancy numbers fool you. I mean, you do the same thing as if it was 2x. Do the same thing as if it was 2x and an x. You just subtract that over, right? You just bring this along as baggage. Okay, now there's a constant on the right and the two x terms on the left. I can combine the two x terms by subtracting their coefficients. In other words, factor out the x. That means the same thing. Subtract the exponents, aka factor out the x. So it looks like this. It might take you a little while to get used to dealing with funky looking numbers like this, but it's an important skill. Okay? It's just a matter of getting over the intimidation. The process is exactly the same as any other number. So now I've got a number. Oops, I keep touching the wrong thing. I have two screens in front of me, and I keep touching the wrong screen, and it's really confusing. Anyway, I've got x times this quantity, right? And then that's just a number. So I'm just going to divide that out. Divide both sides. Or cross multiply. Take this factor, and it just goes down on the denominator on the right. So it looks like this. Okay? Now you might ask me, couldn't I combine these into one log? And the answer would be yes, you could. But these ones you don't want to combine. But these two you could, and it would actually come out nicer. I don't know why I didn't do that. This would be log of 25, because the 2 goes up here. Log, right, 5 squared. Log of 25 divided by 2. So it'd be log of 25 halves on the bottom. Or log of 12.5, which is nicer. So I probably should have written that as log of 12.5. But this would be correct too. It doesn't say to put them together, right? So together, putting the logs together or leaving them separate, one's not really considered simpler than the other. It's not simplified. So this is perfectly fine. You see answers like this all the time. Okay. Okay, so solve log base 2 of x equals 3. So this is a much simpler one. So this is the logarithm equation. The previous two were exponential equations. I used logarithms to solve them. This is an exponential equation. I'm sorry, a logarithm equation where the variable is in the argument of the log, right? And I need to use exponential functions to solve it. So I need to get rid of the log base 2. So I just take the left side and make it the exponent base 2, and the right side make it the exponent base 2. In other words, I compose both sides of the equation with exponential function base 2. Now the right side there is just 8. And the left side, the 2 and the log base 2 cancel, and you get x equals 8. Done. Okay, now I'm going to solve this one. That was so easy, I was just in a hurry to go to the next one. Well, you still want to use the exponential function base. Here it's going to be base 5. But you want to just have one logarithm. So you use your rules of logarithms to put these two together. So it's going to be log base 5 of x squared over x, which reduces, right? Log base 5 of x squared over x equals 11. I didn't do anything to both sides. I'm just simplifying the left side using rule number 4 for logarithms. And x squared over x, of course, is just x. So now I've got log base 5 of x. Why didn't I simplify it? I don't know. I guess I'm going to do it later. Okay, so I make the log base 5 the exponent and the 11 the exponent base 5. And then on the left, the 5 to the power log base 5, that cancels. And you just get x. X squared over x, which is x. There, finally I wrote it. And then I just put 5 to the 11th in my calculator. And interestingly enough, it's kind of an interesting number, 48,828,125. Has that 125, which is 5 cubed in it. And then it's got all those 8s and 2s. All powers of 2 in front of it. Kind of a weird number. Anyway, that's the solution. Okay. Next.